All right. Good afternoon, everyone. Thanks for taking the time. I know it's been a long day after a couple of years, probably, of lost practice of this. So after a long day, you're here. I appreciate you taking the time. I hope you grabbed your cup of coffee. So I'm Arindam Chatterjee. I'm the Principal General Manager at Microsoft, working on Azure Databricks. My team owns the product end of the relationship of the partnership with Databricks. And with me, I have Hagai from Akamai. He's going to talk to us about the work that they have been doing, Akamai has been doing with Azure Databricks. And so without, let's just jump into it. We're probably a couple of minutes running a little bit late here. So we'll jump right into it, into the technical details. And we'll follow up with, hopefully, a very interactive discussion after his presentation. So Hagai, please.
Thank you. Thank you, everyone. So believe it or not, this is my third talk for today. Yeah, thank you. Thank you. So I apologize if you've seen some of these slides before, but let me give you a quick overview about Akamai. So we are the largest CDN company and cloud security solutions provider. Numbers talk about 30% of internet traffic that are going through the Akamai servers. We have around 350,000 edge servers which are deployed globally and serving all this traffic. And what we do in this workload, we are collecting security events that were detected on the Akamai network, and we use this data to provide analytics and protect our customers. And generally, we make the internet fast, reliable, and secure. So let me tell you about the business problem that we have. We need to provide our customers with real-time, ad hoc analytics over a very extensive data set. So just to give you some numbers, we're getting, for this product, for this type of use case, we get 1.5 gigabytes a second of malicious activity. This translates to something like 6 million records per second and about 4 petabytes of data over the course of 30 days. Again, we need to provide interactive analytics over this data set. And in Akamai, we serve some of the largest enterprises out there. So companies like Airbnb, TikTok, Amazon, Nike, eBay, Adidas, and basically the largest companies, enterprises, and retailers out there. They're all Akamai customers. So it's a simplified architecture. What we have, this is the Akamai Edge, where we get all these events from. We are deployed on Microsoft Azure. We have a receiving layer that gets it. Then we use Kafka and Azure Blob Storage to stream those events. Then on Azure Databricks, we have a streaming pipeline that takes care of all those events and then stores on Delta Lake, which is also sitting on Azure Blob Storage. What you don't see here is you don't see the medallion architecture, kind of the bronze, silver, and gold. We are doing some aggregation, some cleanups and some transformations on the receiving layer, and some more transformations on Azure Databricks. But we definitely don't do any pre-aggregations for this workload. And let me tell you a little bit why. So we have very strict KPIs on data availability and query performance. We need to show events within 5 minutes of occurring at the Akamai network, which leaves very little time for ingestion. That means we need a really, really fast ingestion pipeline. Also, our events cannot be pre-aggregated because we have over 60 different filter combinations that a customer can apply on his data. And also, pre-aggregation adds latency, right? So we do have a very strict SLA that we need to meet of 5 minutes, so we don't have the time to pre-aggregate. And also, logically, we just can't because of the many filter combinations. On the serving layer, on the query side, so queries on this data set can scan hundreds of terabytes of data and still need to return within 10 seconds for the 99 percentile. That's the KPI that we have. And the last thing is that we're not only providing high-level statistics, we're also showing customers the actual raw data. So we are enabling our customers to go and do a drill down to see the actual raw data at the event level. Okay, so let me tell you about how we are doing all this, how we do interactive analytics at scale. So again, this is powered by Azure Databricks. On the ingestion side, what we do is we are leveraging Azure's regional storage. This is something that, I think it's a public preview or something, but this is a storage that can handle really high bandwidth rates, which is what we need. I think a typical storage account on Azure will give you 50 gigabits a second for ingress and egress. And using original storage, we're getting, so I think we're picking around 500 gigabits a second for ingress, and on the receiving layer, on the consumption layer for egress, we can pick around 800 and sometimes even 1 terabit a second for egress. So that's something we really struggled a lot, and using the regional storage on Azure, we were able to get it. So we meet our KPIs. On the caching side, so we do proactive caching. So what we do, we continuously load data onto our VMs because when a query comes in, we try to eliminate the time it takes to actually go to the storage and read it. So what we do is we all the time take data from the storage, and using the Delta cache, the Databricks Delta cache, we just store it on the VM. So we use Azure VMs that has an attached storage to them. And on the query side, like I said, in order to meet this 10 seconds SLA over this huge data set, we had to have an efficient data layout. I'm talking about partitioning, sorting, Z-ordering, all this stuff. We had to have very fast networking and bandwidth, like I said, and obviously enough resources. And the last thing is that in order to really get amazing performance, we had to use VMs that has an attached storage so we can get a high cache hit ratio, which I think is over 90% now. So let me tell you a little bit about the journey with Azure Databricks. So we started small with, I think, 10% of the load, and we slowly increased it while we were identifying bottlenecks, iteratively solving them, communicating them to the team, both Databricks and Microsoft, and fixing them. We were actually getting custom images from Databricks or direct support of engineering from the Microsoft side in order to match some of the products to the scale that we have. We have a daily sync meetings with both companies, Microsoft and Databricks, where we meet together. We talk about performance issues. We talk about solutions. We see direct involvement of engineering on those calls, and we get very low response times. And I think the last thing is we wanted to build a partnership. We didn't just want to come to a vendor and say, hey, we have this, we have this product, we have this workload. We wanted to, we knew this is not going to be an easy ride at this scale. So we wanted to build a partnership with a company or two companies in this case in order to help us, bring our product to production and help evolve the product and help get support in order to match this scale. So yeah, we think we got a scalable solution that finally meets the KPI and really alleviating some of the pressure that we have on our on-prem system. So I didn't talk about it, but we are in the phase of moving from the on-prem to the cloud on Azure, just because our on-prem system is, it's basically falling apart. We cannot add any more customers. We cannot add any more traffic to it, and we cannot add any more products or features. So we just had to find a solution, and we find it on Azure Databricks. And I think this is not working. Okay. So The last thing I want to say is mainly about give you some takeaways from this journey. I've been talking about this product and this journey throughout these days. And I think the main key takeaway that I have is really if you want to walk far, walk together, because that was a big problem to solve. And what we've seen is the bigger the impact, the bigger the problem, the impact of any small inefficiencies that are out there is really going to manifest on that scale. And we had to partner with someone in order to be able to solve this. And the second thing that we learned is separation of storage and compute is great. But if you really, really want to get great performance, you might as well just bring them back together using caching, which is what we do. And that's a very important one. The third one, evaluate bandwidth limits, because throttling can be painful. We didn't even consider this as something that could be a problem. But obviously at this scale, it was, and together with the Azure Databricks team, we were able to solve it either in the form of the regional storage account, and also some other ways such as caching that help us avoid throttling. So last thing I want to say is about the people. Our partnership with Microsoft and Azure Databricks was a crucial step for success because we did get a lot of support, a lot of fixes, a lot of involvement from different people, either engineering and support and architecture along the way, and that's the only way for us to make this happen at this scale. Thank you.
All right, thanks. Thanks, Hagai. So this was, actually, when you talk about engineering problems, the bigger the numbers, the better, the faster the performance, the better. So this was really impressive, the scale at which Akamai is using Azure Databricks and really driving the changes into the underlying storage and networking and everything in Azure. That's quite impressive. So you mentioned you're using so many different services, and you're integrating all of them. Mm-hmm. Tell us more about what kind of challenges do you face? You talked about throttling being one of them.
Yeah.
How did you manage to deal with so many different services?
Yes, yeah, absolutely. So we do have a lot of services running on Azure. We use, we use AKS for many different workloads. We use ADLS and for Delta and some other things that are happening on Azure, and also, the entire Akamai portal is actually running on Azure. So when we went into this process, we kind of had an idea of how we work on Azure. We had some kind of knowledge on the ecosystem, so it was easier for us. But like I said, it was not easy at this scale. So I think the main challenge that I can speak to is mainly around the storage. When we were getting throttled and we realized that there's very little we can do. We can try to pre-cache data and kind of take the hit when we cache the data, and when a query comes in, it's going to read it from the the actual VM. But still, that was not enough. We understood that if we want to ingest at a faster pace and meet the KPI, or we want to allow faster queries without caching them, we really, really need more bandwidth on the storage, and that's exactly what we got. And this feature of regional storage, it felt like, it really felt like it was built for us. It probably was a coincidence, but it really solved the problem for us. So that was great.
Okay, cool. And what about the networking aspects or security, right? I mean, you mentioned a part of the use case for this is security. So what about the security in the system of the overall service end to end?
Yeah, so security is a big thing at Akamai. So we had to go through a very detailed review with our InfoSec team, where they kind of reviewed all the properties of the VNet, the firewall, the IP tables, every little property that could stand out. We just had to go and convince InfoSec that we're good on that. And also, when you do this type of thing with Azure Databricks, we got a lot of support from Microsoft to kind of convince InfoSec infosec, that this is the way to go.
Cool.
Yep.
Cool. So, one of the slides, I think it's probably the last one, you mentioned, I really like, it kind of really gelled with me yesterday when we were preparing for this, that, if you want to walk far, walk together.
Yeah.
And that really speaks to sort of, the partnership that formed between, Akamai, Databricks, and Microsoft.
Yeah.
Given your experience there and, some of the folks in the room, if they're thinking about something like that, what's the best way to go about it, in your opinion?
Yeah. So two things I have to say. One is if you're doing something like this, you're doing something like this at a very high scale, just make sure you understand every little detail that is happening because, like I said, every little inefficiency that was there definitely manifested on this scale. So you have to really, really make sure you understand every piece of the process, both on the storage side and how it works, and on the ingestion side, and definitely on Databricks Delta. That's definitely a key thing. And the second thing is what I would say is, or recommend is, partner with someone. And we chose Azure and Databricks, which helped us a lot. So I think the only way we could make this happen is to partner with a company that sees us not just as a client, but also as a partner to help us, meet our KPIs and solve the problem for us.
Yeah, I mean, I think when we were going through this, the journey, another thing, kind of, as an engineer especially, you kind of appreciate, it takes patience. To kind of start small because you know that you're going to hit problems that you don't even foresee at this point in time.
Yeah.
Right? We all work on distributed systems, but you hit a scale point and boom, some new problem shows up. Solution is not clear. Regional storage accounts being sort of,
absolutely,
one of those examples. What were some of the other unforeseen things, if you will, that maybe you saw and then you were like, okay, let's put our brains together across all three companies?
Yeah, so one thing I can think of is about auto-scaling. So we wanted to, keep our costs on a reasonable level. So for that, we wanted to kind of scale our clusters according to traffic. And the auto-scaling that came out of the box, it was not good enough for us. It was not downscaling the cluster when it needed. It was not upscaling the cluster fast enough. So what we did in this case, we kind of build our own autoscaler that used, the Azure and Databricks API in order to lift up the resources when it's needed. It's based on the Kafka lag. So we're using Kafka, like I said. So we kind of reading and tracking the Kafka lag, and then according to that, we just upscale or downscale the cluster. So that was a key thing for us. We actually give a talk about this little tool, and it helps reduce our costs. So that's good.
Okay. Cool. And perhaps last but not the least, I mean, you solved some significant engineering problems during this journey. As a community of engineers, it doesn't matter what our work affiliations might be with Microsoft, Databricks, and Akamai, but how much of this work and learnings has made its way back into the overall industry, if you will, and others can benefit from as well.
Yeah, so speaking back to the autoscaler that we build, we are planning to open source it. So it's going to be available for the community. Anyone that uses, Kafka for streaming is going to be able to use it in order to, auto-scale the cluster based on Kafka lag and not just based on other parameters, which are sometimes irrelevant when you do streaming. So that's one thing, and we actually have some more things coming up. But that's the main thing I'll say.
Okay.
Yep.
Cool. And actually, speaking of Kafka, I think you mentioned that you're using Confluent Kafka, and this one more example of bringing, an ISV solution that is available on Azure, and bringing that into part of a broader solution. So, do you want to comment on that? Like, what was your experience working with somebody like Confluent on Azure?
Yeah. So we had a lot of experience just working with vanilla Kafka on our on-prem. But then again, for the same reasons, we wanted to work with a managed solution for Kafka. So we chose Confluent, which is, we're running on Azure. It's doing great. And yeah, I think that's it.
Okay. Cool. So I'm the only one asking questions here, but I'll open this up to the floor. I think we have a little incentive also, I think. Where's Rajiv or somebody who's... All right, so you have a question there, so perhaps.
Yeah, hi, thanks. Two questions. One on that last point. I was wondering if you considered event hubs, and maybe you didn't since you were already using Kafka on-prem. And if you did, maybe why you chose to continue with Kafka. And the other question was if you could talk a little bit more about the query layer, if you're, what you're using there, if it's Databricks SQL or some other custom homegrown thing.
Absolutely. So on Kafka, we kind of did something like a lift and shift from the on-prem. So we were using Kafka before, we continue to use Kafka. I don't think we really consider event hubs, so just on that. But on the query side, so what we do, so we have the data in Delta, and then we have a web app that's running, again, on the Akamai portal, which is also on Azure. And using JDBC, we use Spark SQL to just send the queries to the query cluster and just run the query against the Delta table and get the results back. That's a pretty simplified way. There is an intermediary layer in between. So we have an application that gets the query from the backend using HTTP, and then it translates it to a JDBC SQL that we run on Delta, get the results back, do some light transformations, and get it back to the user.
Yeah, assuming on just a couple questions on Delta. Assuming you're putting Delta on your entire data lake, correct?
Yeah.
Okay. With the announcement, one, can you just talk to me about your experience on Delta a little bit? I'd just love to hear kind of what it provides for you and where you leverage it versus regular storage,
absolutely.
and also the announcement of them open sourcing it as somebody that's already been using it, and now with that announcement this morning, I'd love to hear from a customer perspective. What does that mean to you?
Yeah. Okay, so we chose Delta, or generally, the lakehouse architecture, which Databricks is doing, and Delta is part of it, because we wanted to have just one single source for our data. If you don't want to talk about other vendors, but what they'll do is just give you multiple copies of your data to run different workloads. We just wanted to have one source of truth that has everything and can run different workloads, whether it's interactive analytics, which is this case, or machine learning or BI reporting, everything on top of on just one source of data. So that's why we chose Delta Lake, and also the seamless integration with Spark. So we had a team that knows Spark fairly well. So it was just the right technology for us. So this is mainly why we chose it. About the open source, so yeah, that's definitely a great thing for us, because some of the things that are happening inside DBR, you don't really understand because you don't get to see the code. So luckily, we were able to get really great support from Databricks. But now that it's fully open sourced, we're hopefully we can just just look at the code and understand better what's happening. Yeah.
I think there's a question there. Yeah.
Alan.
That was really great, and I appreciate that. Could you just talk a little bit about the business impact for your customers as you make this? You talk a lot about the journey.
Yeah.
As you put these customers, as you move them from landing data on-prem into the cloud, can you talk a little bit about how that impacts them?
Yeah. So first off, the idea to move to the cloud was mainly because our on-prem system could not handle the load anymore. Yeah, it's basically was falling apart. So once we moved to the cloud, we're able to scale indefinitely, and then just get a better experience to our customers, where they don't get downtime or they don't get slowdowns anymore. More on the business impact, I would say that many of our customers are running very large campaigns. So imagine, a big shoe company. They're bringing out a new pair of shoes, where massive amounts of bots are trying to purchase these shoes and then just resell them. So these are massive amounts of traffic that we see from all those botnets. And previously, we were not able to deal with that good enough. We just had to throw some of this traffic coming into the on-prem. I think once we move to Azure, we're not doing this throttling anymore. So we are able to support our customers much better whenever they do campaigns. We get 2 or 3 times the data for that customer. So we just scale the cluster up and keep the customer experience the same. Yep.
Any other questions? Okay. Are you sure? Going once, going twice? Okay, we got one.
Hey, Hagai. I asked a version of this question through Jose earlier this morning, but I'm going to ask it differently this time.
Okay.
So, there's lessons learned, and you talked about it, right? Walk together, so on, right? To go together and so on.
Yeah.
So kind of going back, as your team was envisioning this project and you started, what were some things you wish you had done in the, quote, requirements phase? I mean, I know we do, continuous, but was there some things that you wish you could have thought about early on?
Yeah. Definitely be aware of bandwidth limits. That's something we really didn't take into account. We came from the on-prem. We get, sufficient bandwidth on Hadoop. But when storage and compute is separated, then you really need to take that into account. So that's definitely a thing I would consider. I have to think about it.
I mean, actually, I from the cloud provider end, right? I know we talk about limitless and we talk about the cloud being never face any throttling. That's the expectation customers come to us with. But we still can't break the laws of physics. I mean, there's that much amount of finite capacity per region and so on. So it does have to be engineered through, and I think the work that Akamai has done, identifying, starting small, scaling up, I think that's been invaluable from a purely engineering perspective. I know it kind of sometimes will, from a business side, you're impatient, you're trying to get to your business goal as quickly as possible, but that's where we need to kind of find the balance.
We had a few calls on
that. Yep,
Yeah,
I know.
Absolutely.
I know.
We'll take one more last question.
Okay.
Were all your data sets in Delta format, or were some in Parquet and any other format?
So for this type of workload, it's all Delta, which is essentially Parquet with some metadata, but it is Delta. We do have other workloads running directly on AKS, not using Delta, and they are in Parquet, most of them. Parquet and Avro.
There's one question here in the front.
What is a feature that you really wish Databricks has built or will build for you?
Oh, so yeah, that's. Thank you for asking that. So I think sharding is one thing. Being able to kind of split a Delta table across multiple storages. So, you don't really care about just define a shard key and then, data is split around multiple storages and that doesn't have to sit all in one storage. That's definitely one thing we're trying to put that on the roadmap together with Databricks.
Thank you.
Yep.
So, this morning, I mean, you heard at the keynote, Karthik was talking about sort of the structured, Spark streaming roadmap.
Yeah.
How much of that, would you have loved to have, when you started the project, or you're looking forward to as you evolve?
Yeah, everything. I mean, it's especially around the metadata improvements that were introduced. This is where we struggled a lot because we do have a lot of data, a lot of partition, and a lot of files. So that results in a lot of metadata as well. That's why sometimes they say, metadata is the new big data.
Right.
And some of those improvements are really around, faster metadata handling, and that's definitely one of the things we would like to have.
Cool.
Yeah.
Cool. Excellent. So we have 40 seconds left, according to 36 now. Any other questions? No? All right. Thank you.
Thank you.
Thanks, Agai, for the great talk.